And welcome, students. We are going to get started talking about programming, not coding, which is a little bit more of a rudimentary concept. This is full-on object-oriented programming. And in order to do that, we're going to start off with this lesson called Hello Programming World. So it's an introduction really to object-oriented programming and also C#. So let's first start off by asking, what exactly is programming? How does that differentiate it from, let's say, coding? Because a lot of you have probably done some kind of coding through something like Scratch or Tinker or some other kind of app to kind of get a little bit of experience of how some of these different logical operations work. Well, programming is the writing of instructions or code that tells a computer or machine what task to perform. This is very different from that of coding. Coding is simply you already have an environment created. You have a set of rules and stuff that you operate in. There's like some kind of environment. A lot of coding environments are very drag-drop interface in a style what's known as visual programming. We're going to be using object-oriented, which is much more text-based. Now, a programming language is an artificial language that is used to communicate instructions to the machine. And what I say by artificial is that it's not a natural spoken language. Like you're not going to write in English what you would say. Like the words might be English that you're writing, but you're not using the standard rules and syntax and everything else that goes with the English language. Instead, you're going to be using whatever that language, like C#, Java, etc., whatever their rules are. Now, program code is used in everything from things like your microwave to your television and from gaming consoles like your Xbox, PS4, etc., to tablets and applications. All right, so programming is very widespread. It's not simply just limited to, hey, I'm a nerd, I'm going to write this cool website, or I'm going to make this cool app. It's used in everything, even things such as like modern day automobiles, tractors, any kind of thing you can think of has some kind of computer chip. And a lot of those computers have sometimes specialized code that will then run different things. So programming is very widespread, very used within the world. It's not simply just limited to apps. Now, that being said, how is code different from one machine to the next? Well, the code is the instructions that are needed to perform the task. So when you write a program, you're writing code. Right? You're writing an application. You're writing some kind of thing that's going to do X, Y, or Z. X, Y, or Z representing some kind of task, whether it's doing something as simple as calculating the area of a square, or it could be something much more complex like running a three-dimensional multiplayer MMORPG. All those different things require you to program code, and obviously the complexity varies dramatically based upon what you're doing. And that ties right in here. So what that machine will do varies based upon the code present in the machine. So if you want the machine simply just to calculate volume, it's going to calculate volume if that's what's present in the code. If you want the machine to be able to run the popcorn setting when you push a button on your microwave, the code will do that as well. Now, there are several different levels of programming languages. You have machine code assembler, you have interpreter compiler, and you have object-oriented. Now, there's another tier, which is natural languages, but we're not really going to talk about those because they tend not to be as intuitive for what we're going to be talking about here. So let's look at the different levels of programming here. Let's start by talking about the levels of code. Now, the first one is machine code. All right, machine code, when you think of it, what's the first thing that pops in mind? Well, obviously a machine, so something like a computer. All right, assembler, all right, easy way to remember this one is assembler is very close to assembly, like an assembly line, and a lot of times that's where you will see this kind of code be implemented is in machine or manufacturing type environments. Interpreter or compiler languages, the most famous of course is C. And then you have object-oriented, which is what most modern-day programming languages are developed in. So now let's look at each of these and see what type of tasks they're best used for. So machine code is what operates and controls the machine directly. It's very fast and efficient. Like no other of these language levels So assembler, interpreter, object-oriented are as fast as machine code because machine code is ultimately the language the computer is going to talk in. All right. Now, the downside of machine code is that it's very difficult to learn and edit. So things such as binary or hexadecimal, yes, there are tools and tricks you can use to help you, but you can't go and write a full game in hexadecimal easily as you could with something that might be an object-oriented, simply because of the complexity that quickly grows. It's like exponential compared to that if you use something like an object-oriented approach. Not saying it's impossible, but it's very, very complex. And also because it's very difficult to edit. If you ever have looked at a binary or hexadecimal program, it's literally just if it's binary, it's just a long, never-ending chain of zeros and ones that might be broken up depending on what you're using into like chunks of like 8 or 16. Similarly with hexadecimal, it's numbers going from 0 to F, and those are typically broken up in chunks of 8 to 4, 8. So it's not really that easy to look at and really kind of do anything with. But for the computer, it's great. And ultimately, everything of those higher levels, assembler, interpreter, object-oriented, part of their job is to take those different things and turn it down into machine code. So machine code is ultimately the language of the machine. All right. Now, assembler is very similar to machine code. Right. However, one of the big advantages of the assemblers is that it's readable by the programmer. All right. Now, the reason why it's assembled is because it has to be assembled, so the machine has to, pretty much take it, put it all together, big thing, instruction, prior to it being used on the machine. So a good example, this sounds like Fortran. If anyone has ever looked at these kind of languages, they're very basic in their instruction. You'll have, really simple commands in there. If you ever take, like, for example, computers and logic with me, you'll see that we use things like and, or, your logic gates are examples of these things. You might have an instruction like loop. You might have an instruction like break, but they're very simple instructions. You can't really do anything complex. Right? And that's because the type of task that assembler is going to use is not very complex. Now, interpreter or compiler languages are languages like C, and C is considered one of the most, it's like the parent language to a lot of modern languages today. But with those languages, the code was written in a much more natural form. Rather than using abstract terms just like loop or break, we started pulling in more syntax from things like in the English language, which then the program, was interpreted and compiled by a compiler in order to run the machine. Now, at this point, the reason why we say interpreter/compiler is because those were two different applications. You had an interpreter, which would interpret the code that you had written from its natural, like, text-based form into the machine code, and then you would have a compiler that would then compile that code in order to check it for errors. So very different from object-oriented, which a lot of times that's all now integrated into one environment. All right, in object-oriented, were developed to form what are known as higher-level tasks. The code was written to develop objects, quote unquote, that could manipulate data. And when I talk about objects, I'm talking about an abstract concept here. It's not a physical object, but it's kind of an abstract thing. So let's talk about those object-oriented languages, since that's what we're primarily going to be working with. So the first one I'm going to mention, I'm just going to talk about a few of them here, is C++. And you might have heard of C++. This has been around since 1983, and it was the successor to the aforementioned C. Now, it was originally called, when it came out, C with classes, but they renamed it to C++ as a pun on the plus incrementer. Plus meaning add 1. So they had a little bit of a sense of humor. Now, C++ combines both the features of high and low-level languages and is often called an intermediate language. It's called intermediate because it's using both high-level and low-level, so it's kind of acting as that bridge between them. Now, Java is another language that you might be familiar with, especially if you ever have like the Java updates come up. Yes, that's an application using Java. It's not you writing in Java. That's two different things. And also, Java is very different from JavaScript. please note JavaScript is used in web page development and it's something totally different. Now, Java itself appeared in 1995 from Sun Microsystems, and it had much of the same syntax that C++ did, so things such as using curly brackets, using semicolons in order to end a statement. But at the same time, Java lacked many of the low-level functions that were in C++. So if you still wanted to access those lower-level functions that could really dig into the machine's hardware, you would need to use C++. Now, the advantage of Java, because it didn't rely on those low-level functions, is that it wasn't necessarily tied to one machine or one type of machine. It was intended as you write the code once, you can run it anywhere. Right? AKA Java was cross-platform. So if you wrote a Java application for a PC, theoretically, as long as you have the Java libraries installed, that same application should be able to run without issue on a Mac or Linux or any other platform that can support it. Now, the final language we're going to talk about, which is the one that we're going to learn for this class, is C#. This was written to develop along Microsoft's .NET platform in 2000. C# is similar to Java in much of the syntax, but has grown divergent over time. Remember how I said that Java was kind of like C++? Well, C# was kind of like Java. In fact, a lot of the similar structures for how you create objects in C# are very similar to what you see in Java. But as I mentioned, they have diverged over time. So there's been new things that have been added. And there's different ways of doing things in C# that you would have to be able to do in Java, and vice versa. All right. So I'll look at C#, and I'm going to spiral us back eventually here to talk a little bit about what an object is in object-oriented languages. But with the C#, it's important to note that while things such as the AP test and numerous applications use Java, there's still a vast number of users that use things like C++ and C# and many other programming languages. So just because you learn one language does not mean that you're not marketable, and at the same time, it does not mean that you can't learn another language. So the biggest thing is once you learn how to do something in one language, you just simply ask, okay, how do I do it in another? Now, with C#, this is used in various functionalities today, which includes things such as app development, the web, a lot of web apps or web development extensions, and much, much more. All right, so C# is not limited to simply just like a little novelty thing. It is a full-fledged programming language. Now, we're going to start looking at C# with our what's known as the standard program, Hello World. So let me just go ahead and get us over here to looking at how that code is going to look. All right, so before I get us in here, I'm just going to quickly switch us over to Visual Studio. This is the application we're going to be using here for this class. You can just, of course, find it here. It's going to be all the way down here. It's Visual Studio. I'm using 2017. You might have an older version, newer version, depending on what you're using. It's very important, though, that when you do this, do not open Blend. Don't open this. This is a slightly different app. You want to make sure you have the full version of Visual Studio. Blend is slightly different. All right, once you get here, it's going to ask you to sign in. So I'm going to click on that, and it's going to say we're getting things ready. And this might take a little bit. All right, but once it's there, it's just going to ask you to sign in. So you just sign in with your school account. Right, and then you can see that it will it'll sign me in, and it just takes a little bit to load, so because it is a kind of a beefy program here. All right, now I've already used Visual Studio before, so if you have a couple other prompts that come up, like it might ask you to pick a theme or something like that, you can do that. Just kind of follow the on-screen navigation here. Now here's a getting started page, and you'll see stuff that will pop up here as we go through this. What I'm going to do for right now, I'm just going to go ahead and close that starting page. Right, and now that we have our application open here, right, and it's applied my skin because I like the dark skin of the application, just I think it's a little easier to see. Let's go ahead and look back at our presentation here. All right, in here I have this code using System Console class program public static void main, string args, console.writeLine, hello world. All right. What this says is when you're using system, this is where the program is going to be running from. So it's running from the system. You have a class named program. This is your main method. And when we say the main method, that is how C# knows to look here for your code. And then this writeLine statement is a code that causes the statement hello world to appear on the console. So keep this in mind as we look at our first code here. So when I'm in Visual Studio, I want to go ahead and open up this application. So I'm going to go over here, I'm going to File, I'm going to go to New, and you can see I have different options here. I can choose a file or I can choose project. What I'm going to want to do is choose project. And immediately it brings up all these different options, and you can see we have Visual C++, Visual C#. I'm going to click on Visual C#. And in here you have several different options. So for example, let me just show you one of these here. So I have a blank app, which is a universal Windows app. I have a console app, which uses the .NET Core. All right. If I look at a blank app, I'm just going to call this, demo. I'm just going to show you this real quick. And when I go to my location here, you'll notice that it creates a location. I want to browse, and I want to change that to be on my N drive, and I'm going to have a program folder called Programming C#. But I want to differentiate because I have other files in there. So let's make a folder called Programming. Select that folder, and so it's going to put in there. I'm going to click OK. All right, and it's going to say, what do I want to support? I just click OK. And then just click OK again. That pops up when you minimize that. And what this does is it tries to create a universal Windows project. Now, we won't be using this interface here, but I just wanted to show you this in case if you click on this, what you can do in case you get in here. So I'm just going to go ahead, I'm going to close this. And you can see it takes a little bit of time to create this app. All right, now I'm going to go back and talk about this code just for a second while this finishes loading. All right, in here you can see that we have these different snips of code. You will need these all in here. What I also want to mention is make sure that you put these curly brackets in here, because if you don't put the curly brackets in here, it's going to cause you a load of headache. Additionally, you'll notice that right here at the end of this first line, there is a semicolon. All right? Very important that you make sure you put your semicolons where they belong. Right? So it finished creating that app here. So in here, I can choose to create my first app and all this other stuff. But right now, I'm not going to worry about this screen right here, because this is targeting a Windows 10 device, which is great, but we are not at that level yet where we want to go to that. So I'm just going to close this, and you can just click the little tab there and it'll close it. I want to instead create a new project, and I'm going to choose Visual C. I'm going to choose a console app. All right. So what we're going to be working with is what is known as a console app, and I'm going to call this Hello World. Okay. It's going to be my programming folder, and then leave the rest as is, and click OK. Okay, and click OK. All right, and here's our code, and you can see this right here looks very similar to the code we have right here, using system, class, program, yada yada yada. See, it's all right in here. Okay. Now, only thing you don't see is the text console, because that text actually belongs for this. So I'm going to come back to talking about some of that stuff here in a second with invoking arguments. So in here, you can see we have using system, namespace, hello world, class, program, static void, mainstream args, console, writeLine, hello world. All right, so let's just talk about that console.writeLine, because this is how we're actually going to get to make a program do something. So in here, I have this console.writeLine. You'll see there's several different pieces in here. There's console, there's writeLine, and there's this dot in these parentheses. Well, invoking an object in an object-oriented programming language means that you're calling a method defined for that object. So the dot right here between console and writeLine is telling the program what method of the object you want to use. So what function, what rule. So counsel is the type of object. Right line is what you want that object to do. Now, what's inside these parentheses will be what's known as an argument. What do you want it? What do you want to pass to that program? What kind of thing do you want to do? You can think of this like as your input. What are you inputting into the program? Right? These are the parameters that are therefore defined for that object. Right? So I'm going to end the PowerPoint and go back to here real quick. And what I want to do real quick is just talk about an object to make it a little bit more sense for you. So I'm just going to fire up Paint here real quick. And let me just go ahead and make real quick a rough sketch of a box here. I'm not looking for it to be perfect. All right, so here I have a box. Now, we can think of this box as an object here. Just shrink that down a little bit so you can see it a little better. Okay, so this is our object right here. Now, when we look at an object like this is our box, and when we think about a box, it has certain properties. All right, those properties are things such as, let me make this a little even smaller now. Make it like 24, 23, 20. Okay. We have things such as length, we have width, we have height. All right. Now, with length and width and height, we can do different things with this box. All right. These are properties that belong to this box. Now, with this box, I can do different things such as finding the area, which is equal, of course, to length times width. You can also find things such as the volume, which is length times width times height. You could also find like things like the surface area, et cetera, et cetera, et cetera. All right, different things that we can do with this. Now, the reason why I'm segueing into this object thing here is to kind of give you a little bit more concrete example of how an object works in programming. Because when we get into the next lesson, we're going to be talking about things like variables and stuff like that. And then we're going to have to come back and talk about this box here. So I just want you to kind of think of this right here as a programming object, and it has different properties. All right, so hold this thought in your mind as we go back and look at our code. All right. In here, I have this basic program. And you notice that it automatically added hello world for me, because by default, it's going to do that. Now, if I want to run my program, you'll see right up here, I have this hello world icon. So if I hit that and I hit run, it takes it a second to build the code and compile it. And you'll see here's the console, pops up, and it disappears. Okay. Now, the reason why it does that, unlike in some IDEs, like for example Java, the console will stay down here so you can see it, is because the program closes right away. So this technically is a hello world program. But what we're going to want to do with all of our programs going forward is just add one line of code right after this, which is going to be console.readline. So we just add this right here, and I'm going to save. And now if I run my program, again, it's going to rebuild, and you can see that the console now remains open. And you can see it says hello world, and it sits there waiting. Now if I want to close this, I can either hit the X here or I can enter and it will close out of it. Right. So that's right there is our first basic program. Now when you go to the part where you're going to have to submit for these various different programs, you are going to want to, of course, save the program, so we just save it. And I'm going to go here, go to this PC, and in here is my wrong program folder, cat2, programming. It was the hello world folder. In here you'll have these different objects, right? So like right here's this program.cs. If what you will want to know, you'll see there's different things here. There's a bin file, an object file, a CS project file. This right here, if I open this with Notepad, this is your code right here. All right. So this program.cs file is the one you're going to upload into the submission page, right? And you just want to make sure that you're naming everything accordingly. So like this is a hello world, then we're going to have like variable lab, input lab, blah blah blah. So just make sure that the code that you upload, because what I'm going to be looking for is this right here. All right. And I think that's enough for today, folks. Kind of a little bit of a long lesson, a little bit introduction. So that's going to be it. Until next time.